The cyclic compounds is further divided into homocyclic and heterocyclic compounds. An atom or group of atoms which largely determine the chemical properties of organic compounds are known as functional groups. If you keep on adding to the successive group of CH2, that another next step of homologous series will be given out. Hello everyone, this is Harshita Bhavasar from Vidhyaashram, Temple of Excellence. Today we are starting up the session 2 of the chapter Organic Chemistry, in that some basic principles and techniques. In the last class, we have discussed about the introduction part of organic compounds and organic chemistry, tetravalency of carbon, shapes of organic compounds, hybridization and bond characteristics, structural representation of organic compounds. These are the topics which we have discussed in the last session. In this session, we are discussing about classification of organic compounds, homologous series and nomenclature of organic compounds. Because classification of organic compounds is the major basic part to understand the whole organic chemistry and the structures. We'll see classification of organic compounds. Usually organic compounds are classified based on the two concepts, that is nature of carbon skeleton and functional group. Okay, based on these two concepts, the classification of organic compounds has been divided. This is the whole classification of organic compounds based on carbon skeleton. See here, organic compounds are nothing but hydrocarbons and their derivatives, right? What are hydrocarbons? The hydrocarbons are the compounds which contain hydrogen and carbon. If they have divided in the first line, it will be acyclic and cyclic. Acyclic can also be called as open chain compounds, means it will be laid in a same plane or same line. In a single line, all the carbon atoms will be allotted. For that kind of compounds, we'll call it as acyclic or open. See here, ethane is the best example. Ethane and propane, butane, these are the examples for acyclic, and this is also called as aliphatic. Here fatose means fats. This aliphatic compounds is another name for the acyclic or open chain compounds. Another side is a cyclic or closed or ring compounds. It will be not in a single chain, it will be in a closed or it is containing a ring structure with a hetero atoms. So, the cyclic compounds is further divided into homocyclic and heterocyclic compounds. Okay. This homocyclic compounds have chain of only carbon atoms, but in the heterocyclic, not only having the carbon atoms, it is having a foreign atoms called nitrogen, oxygen, sulfur, phosphorus and halogen in the carbon chain. We'll see here, homocyclic means, I have told already, that is, it is containing only carbon atoms. It is only having carbon atoms. So, it can be further divided into alicyclic and aromatic, right? Alicyclic compounds do not follow Huckel's rule. This Huckel's rule and the aromaticity you will study in the further sessions. So, this aromatic compounds means it will follow Huckel's rule, okay? And have properties similar to aliphatic compounds. It is having the properties similar to aliphatic compounds. For example, cyclopropane, it is in a cyclic structure. Here cyclohexane, cyclo means cyclic, propane, 3 carbon atoms, 1, 2 and 3. This is cyclohexane. Once again, cyclo means cyclic nature, hexane 6 carbon atom. This is cyclohexene because double bond is present. Here tetrahydrofuran, here oxygen is there, that's why. Here once again aromatic compounds, it will follow Huckel's rule and it is further divided into benzenoid compounds and non-benzenoid compounds. What are benzenoid compounds means? It is having benzene ring. See here, this is a benzene, but another compound also if you see, it is containing only benzene ring attached to one another. So if it is having one benzene ring, that is benzene. Another one, if it is 2, that is naphthalene. And if it is 3, that is anthracene, like that. This is non-benzenoid compounds. It doesn't have the benzene ring. This is not a benzene ring, but it is in a cyclic nature attached to oxygen, that will call it as tropone. And if you come to the heterocyclic compound, as I told already, it is having foreign compounds, foreign atoms like nitrogen, oxygen, sulfur, phosphorus and halogen in the carbon chain. See here, it is also ring structure. It may be having single bond, double bond, like that, and containing 2 heteroatoms. These are all the heteroatoms. So one side, if it is attached to heteroatom, the name will be changed. Furon, pyrrole, thiophene. Thio means sulfur, for that pyridine. These are the how the classification of the organic compounds based on the carbon skeleton. We'll see now here. First we'll see acyclic or aliphatic or open chain compounds. Compounds in which carbon atoms arranged in the form of a straight chain or a branched chain. Okay, we'll call it as acyclic or aliphatic. It doesn't have a cyclic nature, but it is having a straight chain or a branched chain. See here, this is a propane. 1, 2, 3. 3 carbon atoms, but it is in a same chain. That's why here prop 3 carbon ane. This ane, because for it is having only single bonded structure. This is having only one branch, and if you add it to here also, it will be same. That's why isopentane. See here, isobutylamine, because NH2, this is amine functional group. That's why isobutylamine. And here also propene, because double bond is there. That's why ene. Here propyne, because triple bond is there, propyne. Okay, but all the structures are in the straight chain or branched chain, not in the ring structure. That's why we'll call it as acyclic. Another side, cyclic compounds, compounds in which carbon atoms are linked to each other or to the atoms of other elements in a closed chain or a ring structure. In that, you know that homocyclic and heterocyclic is there. If you see homocyclic can also be called as carbocyclic. Compounds which contain ring made up of carbon atoms only, will call it as homocyclic. That homocyclic again will be divided into alicyclic and aliphatic. Compounds which contain rings of 3 or more carbon atoms are connected by a single or double bond and resembles aliphatic compounds in their property. It may doesn't have bond. See here, only single bond. It may have double bond or more triple bonds also, more double bonds also, but it should be in a cyclic nature. That we'll call it as alicyclic or aliphatic. In this aromatic, compounds consist of at least one benzene ring. Aromatic compounds are further classified as benzenoid and non-benzenoid. This aromatic means should containing one benzene ring. You should not get confused with alicyclic and aromatic. Alicyclic is cyclic in nature. It may be start from 3 carbon also, but this aromatic, it should containing one benzene ring compulsorily. So you should not get confused with aromatic and alicyclic. Okay. If you come to the benzenoid, aromatic compounds consisting of at least one or more fused or isolated benzene ring are called benzenoids. See here, this is one benzene. This is also one benzene ring. It is attached to CH3, right? Its a common name or trivial name is toluene. And here 2 benzene ring fused, that's why naphthalene. 3 benzene ring fused, anthracene. Here 1 benzene ring, it is attached to hydroxy, that is OH, we'll call it as phenol. These are the best example for benzenoids. And if you come to the non-benzenoid, aromatic compounds without benzene ring are called benzenoids. Means there is no need of benzene ring, but it should be in a cyclic nature. See here, one side double bond O is there. Here OH hydroxyl is there. That's why we will call it as tropolone. Here it is not a benzene shape. It is 1, 2, 3, 4, 5, 6, 7. This is 7 carbon atoms are there. If you see only, you will be understand it is nowhere a benzene ring. Tropone. Here azulene. Okay, fused rings are there, but nowhere benzene ring is present. Only it is fused. That's why we'll call it as non-benzenoid. Next is heterocyclic. Cyclic compound consisting of more than one type of atoms in the ring are called heterocyclic. More than that hetero atom should be present. It may be 1 or 2. That kind of compounds we'll call it as heterocyclic compounds. For example, tetrahydrofuran. Heterocyclics are further classified as alicyclic and aromatic. Alicyclic is resembled to aliphatic, and aromatic again benzenoid and non-benzenoid. Compounds containing at least one benzene ring. See here, it is one benzene ring. It is attached to another kind of ring, not benzene, that is indole and quinoline. This is pyridine. Heteroatoms are present. One benzene ring is there. It may attach to another benzene ring or attach to another just cyclic ring also. Non-benzenoid compounds without benzene ring. Nowhere benzene ring is present, but it is cyclic in nature. For that, furan and thiophene are the best examples. Next is classification based on the functional groups. Till now we have seen the classification based on carbon skeleton. Now we are looking up for the classification based on functional groups. What is then functional group? An atom or group of atoms which largely determine the chemical properties of organic compounds are known as functional groups. Example, if in a compound OH is present, then we will tell it as alcohol. If CHO is present, it will come under another category, that is aldehyde. Like that, functional group will determine the overall organic compound. What are the properties, what are the chemical properties, how it will be reacting with another side. Like that, the whole organic compound properties will be determined by the functional group. Based on that functional group only, we are classifying our organic compounds in another way. See here, functional group, class of organic compound, general formula. This is alkene, double bond is present. That's why we'll call it as alkene. The general formula is CnH2n. N is nothing but number of carbon atoms. Here triple bond is there, alkyne. Ene is nothing but double bond. Ine is nothing but triple bond. Ane, you know, single bond. See here, Cn, H2n minus 2. OH means alcohol. And this is the general formula, ROH. R may be alkyl or aryl. This is NH2, amine, RNH2. CHO, aldehyde, RCH4. This is CO, ketone, RCOR. Okay, R may be alkyl like CH2, CH3 like that. Another side R may be ring structured. Any kind, if you added to this R as a general formula, this functional group should be present to determine which class of organic compound is written or what are the properties to identify. Okay, and COOH, that is carboxylic acid, COOR, that is ester, CONH2 amide, COCl acid chloride, CN nitrile, NO2 nitro, OR ether, X is nothing but halogen, that is halogen compounds. Okay, this is a very important table. You have to understand and you have to memorize to identify the each class of organic compound, because after all reading the chapters, you will be get confused by seeing the organic compounds individually. So you have to understand the functional group along with the class of organic compound. Next, we will move on to the homologous series. The group of compounds which have same functional group and have similar chemical properties is called homologous series. What are the characteristic features of homologous series? Can be represented by a general formula. Alkanes, CnH2n plus 2, where N is number of carbon atoms. Alkene CnH2n, alkyne CnH2n minus 2. For example, alkanes CnH2n plus 2. What is N means? Then N is nothing but number of carbon atoms. Alkenes CnH2n, alkynes CnH2n minus 2. The other properties are successive members of the series differ by a CH2 group. What is that differ means? See here, CH4, if it is single carbon atom is there, that is methane. For this, if you add CH2, it will become C2H6. Means next compound, that is ethane. If you add again CH2 for this, it will become C3H8. Means next successive order. Again, if you add CH2 for this, it will become C4H10. Means if you keep on adding CH2 group, it will come next order. That's why they have told successive member of the E series will be differ by CH2 group. It can be prepared by almost similar methods, and successive members of the series show a gradual gradation in their physical properties. Little bit changes will be there in the physical properties, but have similar chemical properties. These are the properties of homologous series. Next, write the general formula for the following sets of molecules. See here, CH2, CH2. This is a alkene. So, CnH2n. See here, CH3, CH2OH. Here, O is present. That's why CnH2n plus 2O. Okay, for alkane, it has attached to the O. That's why that molecular or general formula. Next is nomenclature of organic compounds. Nomenclature, what is nomenclature means? If you want to identify, if you want to name the compounds, or that structure is there, you have to name, or name is there, you want to write the structure, means this nomenclature is very much important. That's why organic compounds are named by trivial system, that is common name, or IUPAC system. First we'll see the overall nomenclature step by step. First one, trivial system. Trivial system is nothing but common name. The earlier system of naming organic compounds, which is based on the source, before so many years only, that IUPAC nomenclature has been started. Before that IUPAC nomenclature has been started, the chemicals or the organic compounds were named based on the origin or source. That we'll call it as trivial name or common name. For example, acetic acid, the Latin or Greek word is acetum. It is a source of vinegar. And the formic acid, formica, is nothing but red ant. From the red ant, one liquid like substance will be formed. That is nothing but formic acid. From the citrus, that is lemon or any kind of orange like that, the citric acid will be present. From urine, the uric acid will be present. This is the origin or the source of the organic compound. That's why they gave the common name like that: acetic acid, formic acid, citric acid and uric acid. But later on, the IUPAC name has been also given out for those acids. This is the IUPAC system. The systematic method of naming organic compounds is recommended by International Union of Pure and Applied Chemistry, is nothing but IUPAC. The IUPAC name of any organic compounds essentially consists of three parts, namely root word, suffix and prefix. Okay. The system made the method of doing the nomenclature over the organic compound. That's why this organization gave a individual or particular names for each and every organic compound on the basis of root word, suffix and prefix. We'll understand now what are root word, suffix and prefix. Root word, it indicates the number of carbon atoms present in the longest possible continuous chain of carbon atoms, including functional group and the multiple bonds. What it does means, in the organic compound, how many number of carbon atoms are present, what kind of bond is present, what kind of functional groups are present. It will be showed in the category of root word. See here, if it is 1 carbon, meth, 2 carbon, eth. If it is 3 carbon, prop, 4 but, 5 pent, 6 hex, 7 hept, 8 oct, 9 non, 10 dec, 11 undec, 12 is dodec. For the number of carbon atoms, you have to use the root word, these terms. Okay. Next is suffix. Suffix indicates the saturated or unsaturated nature of the parent chain, also the functional group present in the molecule. Suffix, saturated means single bond, unsaturated means double or triple bond. Suffix is classified as primary suffix and secondary suffix. In that, primary suffix indicates whether the carbon chain is saturated or unsaturated. Primary suffix will be indicated as carbon, that overall organic compound is saturated or unsaturated. See here, carbon single bond is saturated, you have to name that time ane, A-N-E. If it is double bond unsaturated, E-N-E, ene. Triple bond unsaturated, ine. Okay, you have to name like this. Next, secondary suffix means indicates the nature of the functional group present in the organic compound. What kind of functional group is present, that will be represented by secondary suffix. Alcohol, OH, that will be pronunciated or end by the all, alcohol, right? That's why OL. Aldehyde, CH4, that is aldehyde, that's why AL. Ketone, ON. Carboxylic acid, oic acid. Ester, O8 like benzoate. Amide like benzamide, that is the example. If secondary suffix begins with the vowel A, E, I, O, U and or Y, then the terminal E of primary suffix is dropped. Example, ane plus OL, anol. Like ethane, see here, ethane, if it is attached to alcohol, this E will be dropped off. It will become ethanol. That's what they are telling. If it is starting from a vowel, the end word E will be dropped. Here ethane, E will be dropped down, attached by OL, ethanol will be given. And prefix indicates the nature of substituents present on the parent chain, which will consider as a longest chain of carbon atom, that will be as parent chain. That indicates the nature of substituents attached to it. R means alkyl, X means halogen, chloro, bromo, iodo, fluoro, like that, halo, overall halo. If it is nitro, NO2 is there, nitro. NH2, amino, OR, alkoxy, like that, you have to use before the parent chain. An alkyl group is named by substituting YL for ane in the corresponding alkane. The alkyl group can be also be branched, that we know already. If you want to see the branched propyl and butyl groups with their structures, see here, isopropyl, 1, 2, 3, 3 carbon atoms. The propyl region is little bit branched, that's why iso. This is secondary butyl. Meth, eth, prop, but, 4 carbon atoms. 1 CH, 2 carbon atoms are present, that's why secondary. And here isobutyl, this is tertiary butyl. See here, 1 CH group is there, for that 1, 2, 3. Tertiary means 3. Here overall carbon atoms 4. That's why tertiary butyl. Next is arrangement of prefix, root word and suffix. See now, you know what are root word, what are primary suffix, secondary suffix and prefixes, all the things. But you have to arrange in a order to identify the organic compound or write it in a nomenclature way. So order of IUPAC name is, first prefix you have to write, root word, primary suffix and secondary suffix. See here example. CH3, CH2, CH2Br. First you have to see the number of carbon atoms. 1, 2, 3. 3 carbon atoms. What we have to use the root word? Prop. See here. Before that prefix means you are having the halogen, halo. In that bromo is there. That's why bromo. Root word prop. Primary suffix. Nature of carbon atom. All are single bond. That is saturated. That's why ane. IUPAC name. Bromopropane. Overall. Prefix. Primary root word and primary suffix. See here. Nowhere prefix is there in this compound. 1, 2, 3, 4. 4 carbon atoms, that's why but. Primary suffix, all are single bond, that's why ane. Secondary suffix, alcohol present, that's why OL. OL. The overall, butanol. You can write butane plus all. Butane plus all. But you should know that E will be dropped out. That time it will form butanol. Right? This is how the nomenclature of compounds will be written. See here. Rule. Root word plus primary prefix alkane like this. CH4 methane, C2H6 ethane. These are the table. Root word and for the primary suffix. Okay. This is how the nomenclature of organic compounds will be seen in the straight chain. Okay. Still nomenclature is having so many rules which will be seen in the next session. In the next session, rules for named branched alkanes, naming of cyclic compounds, naming of organic compounds containing functional groups. These are the contents will be seen in the next session. So I hope you have understood whatever I have taught today. So thank you so much. We'll meet in the next session.